Hey, how you doing? Welcome to Bill's Garage. Today we're talking basic circuits, and just kind of, the background, and there's some math in here. I'm going to try to make it real easy on you. Okay, so let's not get panicked about it. I'm going to teach you some Ohm's law. All right, we got three different types of circuits in most automotive environments. We're talking three basic types. We got series, parallel, and then the combination of the two called series parallel, or a combination circuit. Now, most of the circuits that we deal with are series and or parallel. The series parallel really not used too much, although there is some funky lighting stuff that does use it. Talk about that in a minute. Oh, wow. All right, series. So here's a simple series circuit, and this one's showing several loads. 1, 2, 3, 4. Okay? Series circuits, there's one path. This is the battery or the power supply down here. I got 12 volts. So if we look, I got 2 ohms, okay? I got a 5 ohm one. I got a 4 ohm one. This is resistance, and if you're not sure what that is, go back and watch the last video. I'll put a link on it. And then a 1 ohm one. So look, because there's one path, okay, there's one path, we have 12 volts, there's only one path for the amperage to flow. Remember, amperage is a product of resistance, okay? Amperage and resistance are tied together along with volts, and we're going to put all those together today. But in a series circuit, since there's only one path, if I disconnect anywhere, if there's a break in the circuit and open in the circuit anywhere along this path, current stops. And amperage is measured, at one place in the circuit. So the amperage in the circuit is the same everywhere. We okay with this? And I could show you the math. We are going to do the math. Now, we have 12 volts, and based on resistance, there's a certain amount of voltage that's going to be consumed over each load. And we're going to do this when we start working on the ATEX. I'm going to show you this. But since we only have 12 volts to work with, the total number of volts that we can drop across these loads is 12. Get it? So we only have 12 volts. That's all we got to work with. Okay? There's a specified amperage, and that's the same throughout the whole circuit. But we drop a certain amount of volts at each load. And each load, because each resistance is different, each load is going to have a different voltage drop. Stay with me. It's coming. All right. So this is a parallel circuit. Now this one's different than the other one. We have multiple branches with a load on each branch. Okay? And there's that means that each of these loads has 12 volts dropping across it. So this one is 4 ohms. How much volts are dropping across it? 12, because it's got 12 on both sides. It's kind of like Oprah. You get 12 volts, you get 12 volts, you get 12 volts. Maybe I shouldn't use Oprah. Anyways, but if we disconnect any one of these branches, the current only stops in that affected branch, unless we have an open here, and then that affects all of these guys. If we have an open here, that affects these two. Get it? Get it? So equal source voltage is dropped across each load, parallel circuit, and there's multiple paths to follow. Do you get this? More on this in the next parallel stuff. Anyways, here's a series parallel. Now this looks rather complicated, and it is, and it's really not used too much. It's like, old school dash lights, some turn signal stuff. We'll talk about that. That's another class, electrical 2, if you must know. But this is the series parallel. Okay, here's the Ohm's law, dude, and this is George Simon Ohm. Old dead guy laws are real common in this, and it's a formula that we use to figure out the relationship between voltage, current, and resistance. Okay, there's three basic formulas to this. I mean, it's all the same formula, but there's three basic ones that you need to know, and yeah, you need to know these. Yeah, we're going to be using these. You should write this stuff down, because it's going to come up again and again. Got it? All right. So look, if you don't take anything else out of this, and I mentioned this in the last one, and it's so important I'm mentioning it again, if we change the resistance, the current changes. So as resistance goes up, current goes down. Well, voltage will drop also unless we hold voltage the same. Okay? So here, just you can look at these arrows. Honestly, they're important, but I'm not going to go through every single one of these. Okay? But you can see the relationship between them. Okay? Here's your math. So we have volts, ohms, and amps. Okay? And those three properties are related together, arrows. If you have two of the values, you can solve for the third. This is where the math comes in. So if I know amps and ohms, I can figure out volts. I take amps times ohms gives me volts. Got it? All right. So first thing we need to do on this is we need to calculate the total resistance. So we're going to take a series circuit because that's easier. Remember, there's one path to follow in a series circuit. So if calculating the series circuit resistance is really easy, we just add them all up. It's different for a parallel. More on this next presentation. But it's real easy. So we add them all up. You know, I got, 2 plus 5 plus 4 plus 1 plus, well, equals, we okay? 12. 12 what? 12 ohms. 12 resistance. 12 ohms resistance. Get it? Okay. So I know how many volts, right? And I know how much resistance it is, so I can figure out the amps in the circuit. And that's pretty simple, okay? So I take 12 volts divided by 12 ohms. So 12 divided by 12 is, wait for it, 1. 1 watt, 1 amp. So remember, this is a series circuit, so there's only one path for the amps to travel, okay? So how many amps are going through this load right here? 1. How many amps are going through this load right here? 1. How many amps are going through this load right here? 1. See where I'm going? How many amps are traveling through this point right here? Well, 1. It's a series circuit. It's only one path. It's the same in the entire circuit. 1. Get it? So now that we know how many amps are flowing through each one of these loads, it's actually pretty simple. Using Ohm's law, I know amps and I know ohms, so I could figure out volts. We okay? So I could do this. I already did this for you. It's right here. So I got this one right here. This one right here is 2 ohms. I got 1 amp. I got 2 ohms. And if you look at Ohm's law, that's the Math 101 thing. It shows you take amps multiplied by ohms, it'll give you the volts. So this one is 2 volts, this one is 5 volts, this one is 4 volts, and this one is 1 volt. So I add them all up, I got 12. 12 what? Well, remember I said I have 12 volts in this circuit. Okay? So that's all I have. So it has to add up my voltage drops. I can check my math on this real easy. In a series circuit, if I add up all the voltage drops, it should come up to source voltage.
An electronic circuit is composed of individual electronic components.
Siri, helping me.
Resistors, capacitors.
Sorry. We okay with this? So that's kind of it. It's really pretty simple. Got it? Thanks.